Friends, in this lecture we will study satellite transponder. So satellite transponder generally transmit and receives the signals. So uplink from the Earth station is received by this receiving antenna and given to the duplexer. So what is the function of duplexer? It is a parallelly transmit the signal and also receives the signal. And also antenna use is the same for transmission and reception of a signal. So first this antenna receives the uplink signal from the Earth station and that signal is given to the RF front end. So what is RF front end? This is a front end amplifier which amplifies the signal. It also improves the signal to noise ratio, also improves the selectivity, sensitivity of that signal. Then output of RF front end is given to the processing block, that is here demodulation and remodulation of that signal is performed. Then output of this processing block is given to the power amplifier to increase the power level of that signal. So these are the main functional blocks of this transponder. Then what is transponder? We can again mention that is it is a combination of transmitter and receiver. As there is a parallel transmission and reception there, this transponder provides the larger bandwidth, and this is an important function of transponder. Therefore we can transmit larger data, or we can transmit large number of signals through this transponder. What are the functions of transponder? As previously mentioned, it provides the amplification, and second function is it provides frequency down conversion. Okay. Then next we will see the typical transponder arrangement. So this is a typical transponder arrangement as shown in this figure. So in this typical transponder arrangement, firstly here as shown in this figure, it consists of input filter. So input filter, then receiver or down converter is there, then input multiplexer is there, then traveling wave tube amplifier is there, then output multiplexer, then output filter is used there. So this diagram is very large, but you can understand this block diagram by simply understanding main blocks, that is the input filter, and main blocks are repeated again and again here. So if we draw first diagram in that input filter, down converter, mux, output mux, filter, then repeatedly all blocks are same in this diagram. So one by one we will study the functions of each block. So first is the input filter. So input filter is basically band pass filter having a bandwidth of 600 megahertz, and this filters the signal, and output of that filter signal is given to the amplifier. Here not shown amplifier, but basically given to the amplifier, and generally parametric amplifiers are used. Parametric amplifiers, generally gallium arsenide FET, that is a low noise amplifiers, are used. Output of that amplifier is down converted to 3.7 to 4.2 gigahertz for C band, that is output is down converted to 3.7 to 4.2 gigahertz. Then output of this down converter is again amplified using gallium arsenide FET. Output of this gallium arsenide FET is again given to the input multiplexer. Generally input multiplexer consists of circulators, input filters, and equalizers. Then output of this input multiplexer is again given to the traveling wave tube amplifier, which is a traveling wave tube amplifier converts low signal to the high signal, and output of TWTA is again given to the output filter. That is again that output is transmitted to the earth, and similar operation is same for this diagram, and this is a typical arrangement for the transponder. So in satellite, the transponder is a heart of any satellite. So this is a important block in satellite communication. Number of satellites, that is satellite consists of number of transponders 10 to 12. According to requirement you can use n number of transponders in satellite. So this is regarding transponder, and in the next lecture we will study in detail what is a single convergent, double convergent transponder in detail. Okay.